So in this video, we will continue with section 5.2 and balancing chemical equations, but we will go through more complex examples. And let's start with ammonia. So the text of the problem says, under appropriate conditions at 1000 degrees Celsius, ammonia gas reacts with oxygen gas to produce gaseous nitrogen monoxide and steam. So the first step is to write the skeletal equation, which means just your reactant and product formulas. So here in words, it would be ammonia, it's a gas, reacts with oxygen gas to produce, so that's when you put the arrow, nitrogen monoxide gas, and steam. Steam is water in its gaseous state, so water as a gas. So ammonia, the formula is NH3. There is no other way to find this formula than know it. So ammonia is like water, a compound that you need to know the formula if you're given the name. And so it's NH3 in the gas state plus oxygen. Oxygen from the air is O2, the diatomic molecule, gives nitrogen monoxide. Nitrogen monoxide is a non-metal. It's made of non-metals only, nitrogen and oxygen. Mono in front of oxide tells you it's only one oxygen, and nitrogen with no prefixes because it's the first non-metal. It also tells you that it's one nitrogen. So it's NO. And then water, H2O. So that's the skeletal equation. The next step is to calculate or count the number of atoms on each side. So let's start with nitrogen. We have one nitrogen in ammonia and one nitrogen in NO. Hydrogen, we have 3 hydrogens on the left, 2 hydrogens on the right from water and from ammonia. Oxygen, we have 2 oxygen on the left and 2 oxygen on the right. 1 oxygen from nitrogen monoxide and 1 oxygen from water. So looking at the count here, we see that nitrogen is balanced and oxygen is balanced. Hydrogen is not balanced. So you will want to write coefficient to balance hydrogen. There is 3 and 2. When you have 3 and 2, you have to take the least common multiple of 3 and 2, and that's going to be 6. Which means you will need to multiply by 2 on the left side and by 3 on the right side. So the coefficient 2 will go in front of ammonia because that's the molecule that has the hydrogen. And you see that 2 times 3 hydrogens is going to be 6 hydrogens on the left. On the right, the 3 will go in front of water because that's the molecule with the hydrogen. And 3 times 2 will be 6 hydrogens on the right. So we use coefficient to balance hydrogen, and we have a 2 and a 3 now in front of ammonia and water. We need to count our atoms again. So nitrogen, we have 2 on the left and 1 on the right. Hydrogen, we have 6 on the left, 2 times 3 from the ammonia. And 6 on the right, 3 times 2 from the water. Next, oxygen. We have 2 oxygens on the left, and on the right, the count has changed. We still have 1 from NO, 1 oxygen from NO, but 3 times 1, 3 oxygens from the water. So that's 4 oxygen on the right. So, and we can see that we have unbalanced nitrogen as well. By putting a 2 in front of ammonia, it changes the count of nitrogen. So nitrogen and oxygen are not balanced anymore. So let's balance nitrogen first. So you see that you have 2 nitrogen on the left, 1 nitrogen on the right. So let's make it 2 on the right by placing a 2 in front of NO, the molecule that has the nitrogen. We will balance nitrogen. So if we count again, we have 2 nitrogens on the left from ammonia and 2 nitrogens on the right from nitrogen monoxide. Hydrogen, we have still 6, 2 times 3 from the ammonia and 6 on the right from the water. Oxygen, we still have 2 oxygen on the left, and we now have 2 oxygens from the NO plus 3 oxygens from the water. So that's 5. So nitrogen and hydrogen are balanced, but not oxygen. So we need to balance oxygen. And so when you are forced to attack an element that is in 3 or more compounds, like here you see that you have oxygen in 3 compounds, find where it is uncombined. So here it's uncombined on the left side with oxygen, the diatomic molecule O2. You can find a coefficient to make it any amount you want, even if that factor is a fraction. So to simplify your duty here, you want to make a coefficient, whatever it needs to be, in front of O2, the oxygen gas, because that will only affect the oxygen. And this way you can find a way to balance your equation. So we have 5 oxygen on the right, and we need 5 on the left. To have 5 on the left, we will need to multiply by 2.5 the molecule of oxygen. So you will add a coefficient of 2.5 in front of O2. And this way we will balance oxygen without disturbing the number of nitrogen and hydrogen. However, coefficients must be whole numbers. They cannot be fractions or decimals. So you will need to multiply all the coefficients by a number to eliminate the fractions. For example, if you have a decimal number that ends in 0.5, or that means a fraction over 2, then you will multiply all the coefficients by 2. If you have a coefficient that ends in 0.33, or it's a fraction over 3, then you will multiply all the coefficients by 3. If you have a coefficient that is 0.25 or a fraction over 4, then you will need to multiply everything by 4. So that means here we have parentheses around the whole equation, and we will say that we will multiply by 2 so that we will get rid of the 2.5 and make it a whole number. When we multiply by 2, it's only the coefficient that we multiply. So let's start with ammonia. In front of ammonia, there is a coefficient 2 times 2 is going to be 4. 2.5 times 2 is going to be 5 in front of oxygen. 2 times 2 is going to be 4 in front of NO. And 3 times 2 is going to be 6 in front of water. So let's make sure that this is balanced still. Let's count nitrogens. We have 4 nitrogens on the left from ammonia and 4 nitrogens on the right from NO. Hydrogen, we have 4 times 3 on the left, that's 12. And on the right, we have 6 times 2, and that's also 12 for hydrogen. Oxygen, we have 5 times 2, it's 10. Plus, on the right, we have 4 oxygens from NO plus 6 oxygens from H2O. So 6 plus 4 is 10. So we also have balanced oxygen. So all elements are balanced, and this would be the final answer for the combustion of ammonia. So let's go through some practice about benzene. Before its toxicity was discovered, benzene was used to decaffeinate coffee. or in aftershave lotions because of its pleasant smell, or as an industrial solvent to degrease metals. Benzene is a flammable liquid that will catch on fire if exposed to a spark in presence of oxygen. So here you have the skeletal equation of the combustion reaction of benzene. So as always, when you have a combustion reaction, you have oxygen as part of the reactant on the left side, and you have carbon dioxide and water on the right side, produced from the combustion of a compound made of carbon and hydrogen. So let's count the number of atoms of each kind. So let's start with carbon. Carbon, we have 6 on the left and 1 on the right from CO2. Hydrogen, we have 6 hydrogen on the left from benzene and 2 from water on the right. Oxygen, 2 oxygen on the left from oxygen, and on the right we have 2 oxygen in carbon dioxide plus 1 oxygen in water, so that's 3. So we need to balance these elements in the order they are showing up here. So first, carbon. Carbon, you want to multiply carbon by 6 on the right side because we have 6 on the left. Let's make it 6 on the right. So we will multiply on the right by 6, and this coefficient of 6 will go in front of CO2 because that's the molecule that has the carbon. And you can see there is only 1 carbon per formula. So 6 times 1 is going to be 6 carbon on the right. Hydrogen, there is 6 on the left, 2 on the right. Let's make it 6 on the right as well. And that means we will need to multiply by 3 because we already have 2. So times 3 is going to be 6. And the coefficient 3 will go in front of water because that's the molecule that has the hydrogens. And we see that 3 times 2 hydrogen is going to be 6 hydrogens on the right. Oxygen, we have the molecule of oxygen with 2 on the left, and we need to recount the number of oxygen on the right because you see now that the coefficient we placed in front of CO2 and water will change the number of oxygens in those on that side, on the right side. So let's count again the number of oxygen on the right. We have 6 times 2 from CO2 plus 3 times 1 from the water. So 6 times 2 is 12, plus 3 from water, it's 15 in total. So we have 15 oxygens on the right, but still only 2 on the left. So when you have an odd number like that, unfortunately, oxygen is by itself on the left side. So you want to make the coefficient in front of oxygen so that it will match that odd number on the right. So because whatever you put in front of O2 will be multiplied by 2 from the molecule of oxygen. So it's going to be half of 15, which is 7.5. Because when you multiply 7.5 by 2, it's 15. So we will multiply by 7.5 and we'll place that in front of O2. And 7.5 times 2, that will be 15 oxygen on the left. However, as you know, we cannot keep those decimal, we cannot keep a coefficient in the shape of a decimal or a fraction. So that means we will need to multiply all coefficients by 2. By 2 here because we have 7.5, and 7.5 multiplied by 2 will be an integer, a whole number. So multiplying the coefficient in front of C6, H6, it's a 1 now, so multiply by 2 means you will have 2 benzene. 7.5 times 2 is 15 in front of oxygen. 6 times 2 is 12 in front of CO2. And 3 times 2 is 6 in front of H2O. So let's verify that this is balanced. Let's count the carbon. We have 2 times 6 on the left and 12 on the right, 12 times 1. And so that's the same, 12 on both sides. Hydrogen, we have 2 times 6 again on the left. And on the right, we have, from the molecule of water, 6 times 2. So it's 12 on both sides. Oxygen, we have 15 times 2 on the left. That's 30. And on the right, we have 12 times 2 for carbon dioxide, plus 6 times 1 from water. So that's 12 times 2 is 24, plus 6 is 30. So we have 30 oxygens on both sides. So the mass is conserved, and this equation is balanced. Let's go through another practice and use the combustion of liquid butane in a lighter. So when you have a lighter, you roll the stone and it makes a spark, and it opens the container that contains the liquid butane, and the formula is C4H10, and that burns it. Combustion, remember, is synonymous to burning. And whenever you're burning, you need oxygen from the air. So when you're burning butane, you have butane plus oxygen, O2 as a gas that came from the air. And you're producing carbon dioxide and water because butane is again made of carbon and hydrogens only. So carbon dioxide and water are what is typically produced during combustions of compound made of carbon and hydrogens only, or oxygen as well. So that's the skeletal equation. Let's count the number of atoms on both sides. Carbon, we have 4 carbon in butane on the left and 1 carbon in CO2 on the right. Hydrogen, we have 10 hydrogens in butane plus 2 hydrogens in water on the right. Oxygen, we have 2 oxygens on the left, and on the right we have 2 from CO2 plus 1 oxygen from water. So that's 3 oxygens on the right. Let's balance them in order, going from carbon, hydrogen to oxygen. So carbon, we have 4 on the left. We want to make it 4 on the right. So we will multiply by 4. And the coefficient 4 will go in front of CO2 because that's the molecule that has the carbon. And that will make 4 carbon on the right. Hydrogen, we have 10 on the left. And let's make it 10 on the right. We have a subscript of 2. If we multiply by 5, that will be 10. And so the 5, the coefficient 5 will go in front of water, and times the subscript 2 is going to be 10 hydrogens on the right. Oxygen, we have 2 on the left, but we have changed the number of oxygen on the right because now we have those coefficients in front of CO2 and H2O that will change the number of oxygen. So we need to recount the number of oxygen. And so in CO2, we have 4 times 2 oxygens. That's going to be 8 plus 5 times 1 from water. So 8 plus 5 is 13. So we have 13 oxygens on the right now. So let's make it 13 on the left, and we can do it because we have oxygen by itself. The molecule of O2 allows us to put any coefficient in front of O2 that will make it balanced. When you have an odd number like 13, because you will need to multiply by the subscript 2, so you want to divide that by 2, and 13 divided by 2 is 6.5. So that 6.5 is a coefficient that goes in front of O2, and 6.5 times 2 is going to be 13 oxygen on the left. So it is balanced, but as you know, we cannot keep a coefficient with decimals or as a fraction. So we will need to multiply all the coefficient by 2 here, because 6.5 by 2 times 2 will be a whole number. So we will need to multiply all coefficients by 2. And so the coefficient in front of butane is 1, so times 2 is going to be 2 butane, plus 6.5 times 2 is going to be 13 oxygen on the left. On the right, 4 times 2 is going to be 8 carbon dioxide, and 5 times 2 is going to be 10 water molecules. So let's make sure this is balanced. Let's count the carbons. On the left, we have 2 times 4 is 8. On the right, we have 8. So 8 and 8, it's balanced for carbon. Hydrogen, we have 2 times 10 on the left. And on the right, we have 10 times 2 from the molecule of water. And so that's 20 on both sides. Oxygen, we have 13 times 2, 26 on the left. And on the right, we have 8 times 2 from carbon dioxide, plus 10 times 1 from water. 8 times 2 is 16, plus 10 is 26. So we have the same number of oxygen on both sides. So this is the final answer for this equation. It is now balanced.